Hi children, how are you all? I hope all you are fine. Children, in that previous video, we discussed about that properties of rational numbers. The first property, closure property we discussed, no? Now here see that the second property, that is a commutative property. What is that next one, ma? Commutative property. Okay, commutative property, here what is the definition? Okay, let A by B and C by D are any two rational numbers, okay, let A by B and C by D are any two rational numbers, then A by B plus C by D, okay, A by B star C by D, which is equals to C by D star A by B. Okay, just observe this one, ma. Just I changed the order only. What is that? A by B star C by D is equal to C by D star A by B. Okay, now here see that these two also belongs to that rational numbers. When it is possible, ma, A by B and C by D are any two rational numbers. If you add those two rational numbers in any order, add those two rational numbers in any order. Here star we can take it as addition, subtraction, multiplication, division. Clear, ma? Star be addition, subtraction, multiplication and division. So, 4 fundamental operations also here you have to apply, just like that closure property only. Okay, here see that the first one comes under that addition, Okay, now here see that A by B, let A by B is equals to 2 by 5. Totally like fractions only I am taking here. Why? Because for your understanding purpose. Okay, you can take that any unlike fractions also you can choose here, and in the same way negative values also you can take. Okay, first see that for understanding the concept only I taken like this. A by B is equal to 2 by 5. Okay, which is a rational number, and C by D is equals to 3 by 5. This is also a rational number. Okay, then A by B, then see here, mom, A by B plus C by D, A by B plus C by D, which is equals to 2 by 5 plus C by D is equals to 3 by 5. Just add those two numbers here. What is that? Denominator. These two numbers also having that same denominator, no? So that's why right here same denominator 5. Just add the numerators 2 plus 3, which is equals to 2 plus 3, 5 by 5, which is equals to 5 and 5 gets cancelled, again you will get it as 1. Understood? So here this is the value of A by B plus C by D. Now what we have to check? This is LHS, no? RHS we have to check. Okay. Now C by D plus A by B. C by D is equal to how much we taken here? C by D is equals to 3 by 5. Okay, 3 by 5 plus A by B is equal to 2 by 5. Again, what is that answer, ma, here? Again, the denominator is same only, no? That's why here denominator is 5 and it's a numerator 3 plus 2. 3 plus 2 whole by 5, which is equals to 3 plus 2 is equals to 5 by 5. Then here again which is equals to 1. As per this one, what we can understand here, if you add that any two numbers in any order, then again you will get the same resultant. Okay, that's why we will say that rational numbers are commutative under addition. Okay, and in the same way we will call this one as order property also. Why? Because we will call this one as order property, because the sum of any two numbers, if you add, while adding any two numbers in any order, you will get the same resultant. Okay, that's why here A by B plus C by D, which is equal to C by D plus A by B, which is equals to 1. Is it satisfying or not? Those two values also, this value also 1 and this value also 1. So that's why here simply we can write like this, no? That's why A by B plus C by D is equal to C by D plus A by B. From this one what we can say, ma? While adding two numbers in any order, we can add numbers in any order. In any order, we will get the same resultant. We will get the same resultant. Okay, that's why here this property also known as, this property is also known as order property. What is that, ma? This property is also known as order property. Why? Because if you add the two numbers in any order, if you change the order, then also we will get that same resultant only. There is no change will become here in that resultant. Same answer you will get. That's why here you can add that any two numbers in any order. That's why this property also known as order property. Finally, what is that conclusion for this one, ma? Then here rational numbers are commutative under addition. Am I clear, ma? Okay. After that addition, what is that next fundamental operation? That is subtraction. What is that? Subtraction. Okay. In that subtraction, what we have to check here? Let A by B and C by D are any two rational numbers, and here A by B is minus C by D, and in the same way which is equals to C by D minus A by B. Those two are satisfied or not, just we have to check here. Okay. Let A by B is equals to 2 by 7. C by D is equal to 1 by 7. Okay. Then A by B minus C by D, which is equals to here, what we will get, ma? 2 by 7 minus 1 by 7, which is equals to, those two also having that same denominator, no? So that's why right here same denominator 7. And what are those numerators, ma? Here 2 minus 1. Then here 2 minus 1 is equal to 1 by 7. Here we got that resultant as 1 by 7. Now here C by D minus A by B. Now C by D minus A by B. C by D is equal to 1 by 7 minus A by B is equal to 2 by 7, which is equals to, the denominator same only, no? That's why answer in denominator also 7 only. Now here numerators 1 minus 2. 1 minus 2 is equal to 2 minus 1 is 1. 1 minus 2 is equal to minus 1 by 7. Children, just observe that in these two cases also we are having the same resultant. No, here we got that positive value, here we got that negative value. That's why here we can't say that those two values are same. Okay, ma? That's why since here A by B minus C by D not equals to C by D minus A by B. Understood, ma? And here 1 by 7 is not equals to minus 1 by 7. We compare those two, but here those two are not equal. Understood? That's why what is that statement, ma? Here rational numbers are commutative sorry, here commutative or not commutative, are not commutative under subtraction. Okay, understood, ma? That's why here rational numbers are commutative under addition, but here rational numbers are not commutative under subtraction. Okay, now come to that next fundamental operation. What is that, ma? Multiplication. Third fundamental operation is multiplication. Okay, in that multiplication also same process. What is that? Let A by B is equals to 2 by 3, that is a rational number. C by D is equals to 5 by 3, that is also a rational number. Okay, then A by B into C by D, which is equals to 2 by 3 into 5 by 3. Is there anywhere cancellations possible, ma? Cancellations not possible, no? That's why directly take the product of numerators and product of denominators. 2 5 is 10, by 3 3 is 9. Okay, 10 by 9 is a rational number or not? Of course, that is a rational number. And in the same way, now C by D into A by B, which is equals to C by D. C by D is equal to 5 by 3 into A by B is equals to 2 by 3. Again, just take the product of denominators and take the product of numerators. Why? Because cancellation is not possible, no? That's why. Again, 5 2 is 10, 3 3 is 9. Again, we got it as 10 by 9 only, no? Yes. As per this one, what we can say here? A by B into C by D, which is equal to C by D into A by B. Understood, ma? So, that's why here what we can say? Here in this property, if you multiply any two numbers in any order, if you change the order of the numbers, then also we will get the same resultant only. Understood? Yes. Since as per this one, what we can say here? Rational numbers are commutative, under multiplication. Under multiplication. Am I clear to you, children? See that here we taken that A by B and C by D. After that, taking the product of A by B into C by D, here we got it as 10 by 9. By taking the product of C by D and A by B, by changing the order also, we got here same resultant only. Okay, that's why here we can say that rational numbers are commutative under multiplication. Okay, still we are having one more fundamental operation. What is that, ma? Division. What is that fundamental operation? Division. Okay, what is the statement of division here? Again same thing, let A by B is equals to, take that any number which is a rational number, C by D is equals to 4, that is also a rational number, then A by B divided by C by D, then what will happen, ma? A by B is equal to 1 by 2 divided by 4. C by D means 4 only, no? That's why. Okay. Now here which is equals to 1 by 2 whole by 4. Whole by 4 only there means we can write it as the 4 by 1 also, no? Okay. Then here 1 by 2 into, in the denominator we have that fraction. So that fraction become as reciprocal, 1 by 4, and division become as multiplication. Understood? Now just take the product of numerators and take the product of denominators here. 1 into 1 is equal to 1, 2 4s 8. Here we got that 8. Now come to that C by D divided by A by B. Now C by D divided by A by B. C by B is D is equal to 4 divided by A by B is equal to 1 by 2. Okay, ma? Now here 4 by 1 by 2, which is equals to 4 into 1 by 2 become as 2 by 1. That one only again we can write it as 2 also, no? 2 by 1, that is nothing but 2 only. 4 2s 8. Just observe that 1 by 8 value, is it equals to 8, ma? No. 1 by 8 that is a fraction, and here 8. 8 means 8 by 1. 1 by 8 value never equals to 8. Understood? That's why here A by B divided by C by D not equals to C by D divided by A by B. Understood? As per this one, what is the final statement here? Rational numbers are not commutative under division. Not commutative under division. Okay ma. So here division not possible. Once see that which one is possible and which one is not possible. All the 4 fundamental operations also see that. First one, A by B plus C by D, which is equals to C by D plus A by B. What is that property ma here? Commutative property under addition. Under addition. Commutative property under addition. This is satisfies. Come to that subtraction. Is it possible ma? A by B minus C by D not equals to C by D minus A by B. Okay. Under subtraction not possible. And here A by B plus C by D, sorry, A by B into C by D, which is equals to C by D into A by B. This is possible no? Under multiplication. Under multiplication. Clear? Yes. And the last one is A by B divided by C by D not equal to C by D divided by A by B. Okay. From this one what we can say here? Commutative property, rational numbers are commutative under rational numbers are commutative. Commutative under which 2 fundamental operations ma? Under addition and multiplication. Under addition and multiplication. And in the same way, not commutative under, not commutative under subtraction and division. Subtraction and division. Okay. Did you understand this concept ma? So this is about that commutative property. Commutative property holds that addition. Rational numbers holds the commutative property under addition and multiplication only, and not satisfies for that subtraction and division. Okay ma, this is about that commutative property. In that next video we will discuss about that associative property. Okay, thank you all.